Ladies and gentlemen, good morning. A warm welcome to Startup Booster 2024. Now, if you're just outside, you see what's happening here on stage. You're not quite sure what's about to unfold. Well, a suggestion would be come on in, take a seat, get comfy, because if you're looking perhaps at innovation, you're intrigued, you're curious, you'd like to feel the temperature, the pulse of this industry and these new fresh, big ideas that are coming through the industry, certainly you're in the right place. So Startup Booster 2024, this is our competition, the leading competition within the composites industry. There is no, it's the only one. Yes, it is the only one. However, it is the leading competition, the global competition throughout the world in terms of these big ideas in this certain industry as well. So again, this was actually launched way back in 2017, and already we've seen the emergence of more than 1,000 new big ideas, and many of those have moved on to become very successful indeed. Many, as you know already, are actually here as well as exhibitors, moving forward and having those conversations forward with you as well. So again, exciting, intrigued, curious. By the end of this first session, certainly you'll be curious and intrigued to hopefully have conversations with some of the pictures that are here on stage. So this edition, we had more than 100 applications from more than 45 countries, which really, as you can see, really demonstrates the strength and the significance of this competition. We are honored naturally to count on those that support this format, this idea, this concept with our faithful partners of Startup Booster competition. So we thank our main innovation partners, Airbus and Owens Corning. Thank you so much for being with us. And naturally our innovation partner as well, Mercedes-Benz. Right, so out of all of the JEC, all of these applications, JEC actually decided on only 20. So you're about to see today 20 big ideas. Right now, this morning, first 10 of the first category, which is products and materials. And then a little bit later on at 4:30, on this stage, we then see another 10 big ideas in the process, manufacturing and equipment category as well. And remember, regardless of whether the startups on stage, they walk away a winner or not, although that is significant and that is certainly important as well. For you, the audience, for you that are here, again, you're curious, you'd like to know more, you can meet all our startups certainly here, but also at the Startup Village as well, at the beginning of the entrance of hall number 6. So there's a Startup Village at the entrance of hall number 6. That's where all our startups, they have their booths, they're ready for conversations. That's what they're here for. That's what you're here for as well. So again, you're intrigued, you'd like to know more, or even if you like to challenge the startups, the audacity of coming up with an idea they have, you disagree with everything, go up to them, have a conversation and start that conversation forward, because you might actually be pleasantly surprised as well. Okay, so how does this work? It's really simple and really easy to grasp. We have naturally a jury of distinguished experts which will evaluate these startups here on stage. You can do that as well, but although your perspective right now today doesn't count, what does count is what our jury members, how they feel about what they see and what they hear on stage. It's a tough job. It's okay. We don't have to do it. That's their job. And they'll be doing that after the first session and actually the second session. And then tomorrow here on stage again, we will discover, unfold and reveal the 3 winners. So 1 winner from each of the 2 categories. And we also have the best sustainable solution winner. So best sustainable solution, which could be from any one of those 20 as well. Right, let's have a look. You can see behind me right now. These are our jury members. Let me just quickly introduce you them right now. You can see their faces on the screen. You can probably see the back of their heads as they're facing this way, but that's okay. Or actually, we might put them on the screen. In fact, please, a warm welcome to all of our jury members. Head of Composite Manufacturing Technologies at Airbus, Mr. Jelle Blumhoff. Welcome. Thank you so much. We also have the Manager of Future Exterior and Materials from Mercedes-Benz, Karl-Heinz Fuller. Thank you. Head of Safran Composites Ventures, Safran, Florent Ilat. Thank you for being with us. Program Manager and Investment Analyst from Techstars Sustainability Paris, Rebecca Ravini. Thank you for being with us. And VP of Strategic Marketing and R&D from Owens Corning, Chris Skinner. So we have our audience. We have our jury members. All we need now, what do we need now? Naturally, our startup pitchers together with their big ideas. Together with their big ideas as well. So how does this unfold? Very, very simply, 5 minutes. Pitcher will come here, around here, or behind the podium, and share their big idea for 5 minutes. No more. Less if they want, but no more than 5 minutes. After that 5 minutes, we then dig a little bit deeper into underneath the bonnet, as it were, into the idea, the big idea, to really see how the startup ticks and also the idea ticks as well. And that's where we have up to 2 minutes from our jury members, who will be asking the questions that nobody dares to. We'll see what the questions are, but they will ask questions really because they clearly know what they're looking for and looking for the answers that will help them decide who will actually walk away a winner. Right, I think we're ready to start. Are we ready to start? Yes, we are. Ladies and gentlemen, please, a warm welcome to our first startup. And again, as I said, all our startups completely global, a global competition. So it's great that we really have pretty much not every country represented here, but naturally a whole broad scale of startups from across the world, really in this competition to walk away a winner. Please welcome from Denmark, startup very simply called BioHalo.
Good morning, everyone. My name is Johan Liebeton, and it's my pleasure to introduce BioHalo, the biohalogenation company, to you. PFAS, the forever chemicals, also known as per- and polyfluorinated alkyl substances, are causing pollution across the globe, detrimentally impacting not only human health, but also the planetary health. When you look at the production methods, the traditional ones, they are energy intensive, you use a lot of fossil fuel derived feedstock, and most critically, it's very demanding or sometimes even impossible to control the degree of fluorination. And for this reason, it's a nightmare when it comes to the end-of-life management of PFAS. However, PFAS, or the fluorine in it, is a very special element, and we shouldn't say it's the fault of fluorine. Fluorine, actually, when it's present in high-performance materials, it enhances their properties quite a lot, gives them remarkable properties like chemical resistance, heat tolerance, moisture repellency, and electrical insulation. And because of these remarkable properties, PFAS molecules are stable in a range of industries like medtech to aerospace and renewable energy systems. As I already mentioned, it's not fluorine's fault, and therefore we shouldn't kind of underestimate the significance of fluorine and more look for a sustainable alternative of fluorine, how we use it in future. And there our biopolymers enter. Our patented biofluorination technology offers a solution to sustainably marry high performance properties with with sustainability demands, and our solution has lower energy demands. We could use renewable carbon feedstocks, and most critically, we can control the degree of fluorination, and for this reason, make sure that our biomolecules have biodegradability or recyclability properties, so that the end-of-life management is not a problem anymore, and we kind of can overcome this nightmare. When it comes to our market approach, we would like to go for the coating and film sector first. That's where we say our revolution will begin, since it's a low volume, high price market, and the growth trajectories are looking very well. When you look at our timeline, in September 2023, we were accepted into the Venture Lab program of the Bio-Innovation Institute in Copenhagen, getting some money, and this money we use for our proof of concept and upscaling our production in a first phase. And in the next couple of years, we want to upscale even more, and with a seed and Series A, make this possible. Just to maybe emphasize once more how important PFAS is today, the societal cost of forever chemicals are hugely underestimated and underrepresented in the cost today. Just a recent publication by the Nordic Council estimated that in the European Economic Area, the healthcare-related cost of PFAS are between 50 and 86 billion euros, so quite high. And when you look at the PFAS price per kilogram, it's quite low. So we need more sustainable alternatives to overcome like these burdens for society and the environment. When it comes to our engineered bacteria, we use these engineered bacteria to produce sustainable high-performance materials. Our first one is a fluorinated version of PHB, a very common bioplastic, which boasts water repellency properties like PFAS, like PTFE, commonly known as Teflon. So in this regard, we offer a biodegradable polyester, which has advanced properties, and for this reason could replace, in a range of applications, PFAS molecules. The second flagship molecule our technology platform has birthed is 2-fluoromeconic acids, which we can use to produce a range of polymers, which are very interesting and recyclable to replace other PFAS molecules. To summarize our biosustainability proposition, BioHalo provides high-performance materials which marry planetary and human health demands with high-performance properties, which is not offered yet today. And our team consists of 3 founders, Nicolas Krink, Mariela Mencina, and Pablo Nickel, which spearhead BioHalo, and Alberto de Maria, Justine Turlin, and myself are supporting the founders, making this a great adventure. When it comes to BioHalo, I hope I introduced you to it, and make sure to come by our booth to get to know us and start chatting with us. We would be happy. Thank you so much for your attention.
Ladies and gentlemen, hands together for BioHalo. Well done, fantastic. Right, there we are, quite simple, 5 minutes. Let's move on now to our jury members and hear how they felt about what we've just heard. Karl-Heinz, I believe you're beginning with a question.
Yes, thank you very much for your very nice presentation. And I would like to have 2 questions for you. First one is, how do you plan to scale up your technology in terms of, do you have a certain cooperation strategy, or do you want to produce by yourself? That's my first question. And the second question is, for me, degradability is always scaring. You know, we want to create cars which live very long, and then they are sustainable. So how do you think about developing your products for automotive industry which can sustain maybe 30 years and more?
Thank you so much for these great questions. To answer the first one, at the moment we are using contract development and manufacturing partners to scale it up, just to have like the possibility to go from one step to another and see what works, what doesn't work, and to reduce like the capital costs. Later on, of course, when we have a proof of principle, or let's say scalability proof, we also would like to have our own steel in the ground. Let's put it like this. The second question about that biodegradability sounds like, from a high performance perspective, a bit kind of risky. I would argue that since our molecules are very stable, they don't degrade after 1 week or so. And probably we wouldn't recommend you using it like in an agricultural context so that they're exposed to a lot of soil bacteria. But for example, when you think about semiconductors which are coated with PFAS molecules, they are not exposed to a lot of soil bacteria. So there wouldn't be any degradation going on, and recyclability would be much more important. So I think it kind of depends on. We will not be able to replace PFAS in all applications, but there where it makes sense, there is a high chance, I think.
And that unfortunately, no more time. 2 minutes goes very quickly. Ladies and gentlemen, hands together for our first startup, BioHalo. Thank you so much.
Have fun.
Fantastic. Have fun as he walks. He says have fun as he walks. He might be having a lot of fun tomorrow if he walks away a winner. We'll find out tomorrow afternoon once we hear the 3 winners, who the 3 winners are of this competition. Ladies and gentlemen, if you just joined us, again, just come on in, take a seat. This is the Startup Booster competition. The first 10 startups, big ideas, hoping to shake up the industry. We're listening to all of those 10, and we'll find out a winner, one winner of this this session tomorrow afternoon. Let's move on now. So we started in Denmark. We move across to our next startup from the UK, in fact. Please welcome a startup called BioTwin.
Good morning, everyone, and to the judges. My name is Kit Chong, and I am the CEO and co-founder of BioTwin, where we are pioneering the development of low-carbon construction materials. Now, brace yourselves for a wake-up call. By 2050, the very existence of all living beings will hang in the balance due to unchecked global warming. And, will we be here or not? I hope that got your attention. And this is due to high carbon emissions. So for us, we see that carbon emissions is a challenge. And for us, we're focused on the buildings material sector. And this accounts for 11% of global CO2 emissions. And part of this is the steel industry contributing to it. Around 1.8 billion wall studs are being created every single year. And that's a huge carbon burden. Our solution is to make these wall studs out of biomass, specifically out of hemp sheave and hemp fiber, compressed with a thermoplastic binder. Now, why hemp, you might ask? Well, hemp is not just a plant. It's a carbon-absorbing powerhouse. It sucks up 4 times more carbon than trees do. It's fast-growing and relatively cheap feedstock. Now, why a stud? Well, a 3-meter-length steel stud produces 12 kilograms of CO2. And like I mentioned, 1.8 billion of these are made every year. And ours is 0 carbon. So this will empower property developers and contractors to reduce their embodied carbon. And we have the opportunity also to help develop the sound and thermal performance that will help them enhance the walls. Our competition, well, we're up against the steel wall stud manufacturers, but our early data shows that we are beating or at least matching them on everything that you want from a stud. Our business model is twofold. We partner up with the wall system manufacturers, where they include our components in their product portfolio, and then they can sell and distribute to their clients. And the other way is to sell directly to property developers and contractors. Our home market is the UK, but we're poised to expand rapidly across Europe, Asia, US, and the Middle East. Our team, we have a good spread of experience and expertise. I'm focused on the business and operations side. I've had startups before. I've exited 2 successfully. My co-founder, Matt Elton, he heads up product development, and he has extensive design and manufacturing experience. We also have Tim, our technical director, who is focused on manufacturing, and Faria, who is responsible for materials composition. And we also have some angel and VC investors. In terms of milestones, we celebrated our 1-year anniversary, and we've achieved a lot over the past year. And like I mentioned, we have some significant interest from property developers, and we've secured around 3 letters of intents, and we feel encouraged by their feedback and also the drivers that they have to moving more to sustainable materials. Just to give you an example, that this office, 7,500 square meters, around 9% of it is made up of walls and partitions, and that's 400,000 kilograms of CO2. And over the next year, we hope to have produced 1.15 million studs, saving 4 million kilograms of CO2. Our ask is that we are looking for pre-preg manufacturers, customers to do pilot projects, and we're looking to raise 1 million of investment.
We'll never know. No, we will. Right. Ladies and gentlemen, hands together for our startup, BioTwin. Well done. Right. This is where, that's right, don't move, because this is where our jury members, they ask you, or they ask you questions for you to answer. I believe Chris Skinner has a question for BioTwin. Let's hear.
Cool. Thanks, Kit. I mean, it's super interesting. I mean, just could you explain in a bit more detail, okay, the manufacturing process and how you're actually going to make this stuff? I mean, to make it cheaper than steel is pretty impressive, yeah?
Yeah, so we're actually moving into the manufacturing phase right now. We're looking for pre-preg and forming manufacturers. So right now, how we're doing it is we've got about this much of material, squishing it down to about 3 millimeters with a thermoplastic binder that we're working on with BASF. And once we've done our pre-preg, we're pushing it through, forming like clamps and machinery.
Okay, cool, thanks.
Did you think about recyclability of those parts?
Yeah, so that's a really good question. So hemp obviously can go back into the ground. The thermoplastic that we're looking at can be separated. So BASF have told us that this is something that they can separate from the natural materials. And then that thermoplastic can be recycled again.
Okay, I've got another 60 seconds on the clock. Anyone else? Any questions at all? All happy? You're looking, ladies and gentlemen, you can't see what we see. Completely poker face, no idea what they're thinking. Now they're smiling, but before we have no idea. But we'll find out a little bit later on. Ladies and gentlemen, please, hands together for our second startup, BioTwin. Thank you so much.
Thank you.
Also, just to remind you as well, remember, products and materials category, we have one winner from these 10 big ideas that you're hearing right now. But remember, out of the whole 20 big ideas of the Startup Booster competition, again, there's a third prize for the best sustainable solution. So again, as you listen, I'm sure you'll be making up your mind, certainly after this session, who you feel should walk away a winner, and potentially even the best sustainable solution as well. So have a listen to that element naturally as we unfold this session together. Okay, so we started off in Denmark, UK, and now we go over to Germany. Ladies and gentlemen, our third startup of the Startup Booster Competition 2024 is simply called CARBOCON.
if we want to achieve our climate goals, we have to change the construction sector. The construction sector is responsible for more than 50% of CO2 emissions, 50% of waste, consumes more than 60% of resources, and in Germany and France alone, we have more than 100,000 damaged bridges. But what can we do? There are two solutions. First, we have to save our existing structures. Second, we have to build new, but durable and resource efficient. We, as CARBOCON, has the solution for both, thanks to composites and carbon-reinforced concrete. At first, we will talk about strengthening. Just imagine, nowadays, you have a damaged bridge. Typically, you spray 6 to 8 centimeters of shotcrete on the top or the bottom of the existing structures. This additional weight, the bridge cannot carry. What we do, we demolish and build new. We cannot allow this anymore. This is why we developed a new strengthening method called CarboRefit. We use carbon crits, high-performance, non-corrosive carbon crits, small layers of concrete, and we can strengthen existing structures with only 10 millimeters of carbon-reinforced concrete. Compared to conventional strengthening methods, you can see it on the left, shotcrete, you need 7 centimeters. For the same load-bearing capacity, we only need 1 centimeters. But the big advantage is that we can apply our system when every other method fails. We can save those structures thanks to CarboRefit. And if we compare the numbers, demolition or saving, we can save up to 95% of resources, up to 80% of CO2 emission, saving our structures. For this strengthening methods, we have an approval in Germany. And a high amount of practical examples show the huge potential. But sometimes we have to build new. Therefore, we have the second solution as CARBOCON. Just imagine, on the left, you have a steel reinforced beam. On the right, you have a beam reinforced with carbon. Now we have a new three-dimensional carbon reinforcement called CarboTruss. And this CarboTruss element, you can see it on the left, is fully automated. No manual labor is needed anymore. And you can place the fiber wherever you need it. And you can create structures like this, fully automated. Just imagine now you have a fully automated carbon reinforcement, CarboTruss, and now you can place it into the concrete structure and you can place the fibers load-orientated. Now you have a load-orientated, durable, and resource-efficient structure. Compared to conventional steel reinforcement, we can save here 75% of resources and 70% of CO2 emission. And our goal is to place those elements into large-scale bridges. But how do we earn money? For CarboRefit and CarboTruss, we have an approval and a patent. We allow producers to sell our products, concrete and reinforcement, and from every sold item, we get license fees. The market potential is huge. Only in Germany, we have more than 35,000 damaged bridges, only in Germany. And we have more than 1 million missing houses. There's an estimated revenue, it's enormous. And as I mentioned before, climate change is the biggest challenge for the construction sector. And composites, it's the biggest opportunity for composites. Today, I represent CARBOCON. CARBOCON already received many awards because of our innovations. And we are a fully qualified team with experts, researchers, people with PhD, and people with a strong scientific background, like professors. So, if you want to change the construction sector with us together, get in touch with us. Thank you.
Ladies and gentlemen, hands together for CARBOCON. There we are. Confident pitch. Right, again, let's hear from our jury members, and I believe Rebecca from Textile Sustainability Paris has a question.
Yes, thank you so much for your presentation. I would like to have more clarity from when it comes to the roadmap from a commercial point of view, how you think about scaling and what is your strategy there?
Right now we have an approval in Germany, and the next step is we want to transfer it to Europe, but moreover to all other countries, because we have to save many structures. This is the key challenge for climate change, and we have to scale like the new element, the Carbo Trust, because we have to do something, and we as CARBOCON wants to do it first in Germany, then scale it to other countries.
Very interesting presentation. For me, always the question is, there's a mismatch often between the size of the construction industry and the size of the composites industry, and particularly the carbon fiber industry. So have you thought about other reinforcing materials instead of carbon? By the way, I work for a glass company.
This is a good question, because today I showed you the technology. This is the technology how to save structures, the technology how to build new structures. And we can switch carbon into glass, because sometimes we use glass because it has other advantages, but we have more researches going on, because maybe in a few years we have completely other fibers. But the technology is the same, but we have even more CO2 reduction.
We've got 20 seconds on the clock. Quick question, quick answer. No. Happy? Yes, you are absolutely. You're happy. Our audience is happy. You kind of look happy. We'll see how happy you are tomorrow, hopefully, as a winner. Ladies and gentlemen, hands together for CARBOCON. Well done. Congratulations. Right. 3 already, there we are. 3 startups, 3 big ideas, all very diverse, all very, very different. If you had to choose already a winner, who would you choose? It's okay, you don't have to do that. That's the job of, naturally, our jury members as we unfold through this session and tomorrow as well. Right, let's move on to our next big idea, our next startup. This is, again, from the UK. Please welcome, hands together for Cellexcel.
Welcome to Cellexcel, and thank you for giving us the opportunity to present our technology. We are all aware of the need to reduce embedded emissions in our primary materials. And one of the main issues slowing the pace of adoption of biomaterials, and in turn biocomposites, are the physical properties of the biomaterial, specifically water resistance. At Cellexcel, we enable water-resistant biomaterials. And I'm going to emphasize, not through a coating and not through using forever chemicals or technology at all. As you can see here on these images of our technology, on the left-hand side is a dropless test. The untreated fabric is a hemp fabric, has absorbed the water. The right-hand side beads. On the right-hand side is a wicking test where you can clearly see the untreated fabric, the water has wicked through the fabric. No wicking at all on the treated fabric. In this test, we actually took this fabric and cut it and dipped the exposed fibers into the water. If this was a coating, that would have been a natural leak path. The full videos of these are available on our booth at the Startup Village. This visual of the hierarchical structure of cellulose explains our technology and the scale of it. The plant cell here is about the width of 1 human hair. We're operating 100,000 times smaller than that at the cellulose molecular level. Cellulose is present in all plants, so our technology can impact all fibers: knauf, hemp, flax, banana, whatever the local abundant crop is. Our business is not limited by geography. Our technology is of a modular nature, where we have a delivery system, a hand, an attachment mechanism onto the cellulose, and a property-enhancing compound. The initial property we wanted to impact was water resistance, so this is a hydrophobic compound. But as you can see, by changing the property compound, we can impact other properties within the biomaterial, potentially such as strength and certainly antifungal properties. Our technology, therefore, can reach many markets. The first market we decided to focus on was biocomposites, where so many people were asking us to solve the water absorption of biomaterials. In addition, we've contacted and been in place with the electronics industry, where we have taken everyday pieces of paper, treated them to make them highly water resistant, and printed electronic circuit boards, getting great adhesion and clarity, and therefore providing a cost reduction in that supply chain. And we've just started initial conversations with a major brand about highly water resistant biomaterials for use in clothing. The expertise that has been assembled in our team has been a true pleasure to build. We work very much as a team, but leverage each individual's strengths. The team has developed, and we are a matter of weeks away from gaining full patents being granted, and we're continuing to develop our IP portfolio. The team has also been very much outside of the lab, and we've run our technology at scale in the UK at a fabric manufacturer. Cellexcel truly has the ability to power up the use of biomaterials, and critically today enables every composite manufacturer in this room and out there to potentially reduce their embedded emissions by up to 80%. We need to accelerate that today. And to do that, we're looking for more joint development agreements with primes particularly. We're looking for venture capital investment to really unlock the potential of our modular technology. And lastly, I would ask you all to come and visit us and see and touch the technology on display at our booth. You can put water on the fabric, you can see for yourself. Thank you.
Ladies and gentlemen, hands together for Cellexcel. There we are, some bold statements from our pitch right now. Let's dig a little bit deeper. Let's hear from our jury members once again. Rebecca, I believe you have a question.
Thank you so much for this presentation. Could you tell us today who are the main kind of clients that you are targeting?
Yeah, it's gaining traction in this. My biggest challenge so far today has been to convince people it's not using perfluoroelastomer technology in forever chemicals. So we're looking to work with fabric suppliers, pre-preg suppliers into the main supply chain. To do that, we have to gain access to the primes. And the primes have to be embracing their technology and encourage their supply chain to then use it. So our business model is to gain revenue through joint development agreements initially, but ultimately to work with license agreements with the primes, supply support services to their supply chain, and to be the actual supplier of Cellexcel material into that supply chain.
Thank you so much. And if I could ask, last question, what was your previous life before becoming an entrepreneur?
I have run SMEs, typically under 40 million, both in the US and the UK. Grown those, developed the teams, typically a couple of hundred employees, and achieved several realizations. So it's my first startup. And I'd like to, my colleague Jack is out here, and he's the real brains of the operation, because that's the technology. The business side of life is just fun.
30 seconds on the clock. Quick question.
Just one question. Which parts did you patent? Is it a process? You told us you are being granted a patent.
Yeah, so we have a number of patents going through which are very close to being granted, and they are to do with A, the process, and B, the impact of the process. We have tried to keep them as broad-ranging as possible within the scope of getting granted.
Ladies and gentlemen, hands together for our startup here on stage, Cellexcel. Thank you so much. Wonderful. We're moving through, as you can hear, it's getting it's getting tougher and tougher for our jury members to essentially collectively at the end of all this to decide who walks away a winner of this competition. If you had to decide, who would you choose right now? Everybody's got their own perspectives. Let's move on to our next big idea right now on stage of the Startup Booster competition, the first 10 of products and material category, and this is once again over to the UK, and this is called High Temperature Material Systems.
Good morning, everyone. Hi, my name is Dr. Danilo De Salvo, and I'm the CEO of HTMS. We're here to revolutionize the high-temperature composite materials market. Our journey started with a simple question: how can we leverage the exceptional performance of ceramic matrix composites and to lower emissions throughout a multitude of sectors around the world? Today, we're excited to share with you how we're turning this vision into a reality. So let's dive straight into the heart of the problem. Our target market suffers from carbon-intensive, expensive, and thermally inefficient material systems. This not only affects their product performance and efficiency, but is also key for safety. We note the recent press articles that may hinder adoption of more technology in the clean transport ecosystem. So enter our HTMS CMC. We've developed a novel chemistry that allows us to process our ceramic matrix composites at much lower temperature than our competition. This reduces costs by simplified manufacturing methods, significantly lowers our carbon footprint, and excitingly, we can tailor our performance for our customers by novel fiber and matrix combinations. We feel that this is a winning value proposition. This chart shows material cost against temperature capability. As you'd expect, with increased temperature capability, there'll be a significant cost penalty. For our materials, we don't have that cost penalty for this significant increase in temperature capability. This is what we call our HTMS sweet spot. Inside our sweet spot, we have a family of materials, including a cost-efficient thermal shield and an unparalleled fire protection CMC. It's not just our capability per pound or per euro that we're excited about. It's also our production efficiency. We use 50% less CO2 during our production compared to incumbent ceramic and polymer composite systems, and over 75% less CO2 compared to metallics options. But production efficiency is only half the story. In application, we're great as well. Here's an example. We could save 2 million tons of CO2 per year through the use of ceramic composites in gas turbines. That's the equivalent of planting 100 million trees per year. Now let's look at our business strategy. We have 3 phases of development. Initially, we're entering the defense and motorsport sectors, which have lower barriers to entry. These markets are worth approximately $100 billion per year. We then wish to serve the other sectors going through in our phase 2 and phase 3. This market's worth $3 billion per year and is growing strongly at a compound annual growth rate of almost 10%. I now want to share with you 2 success stories before we wrap up. Firstly, we're working with a customer to revolutionize the future of flight. Our customer will take advantage of a multifunctional composite system that's 75% lighter, uses 75% less CO2, is a quarter of the price, and can operate at 400 degrees more than the previous solution. Those are game-changing numbers. Secondly, we're working with an OEM to help protect their passengers through the use of our fire protection CMC. This is half the weight, uses less than half the CO2, costs the same, and has outstanding thermal performance with no ignition during testing. These aren't just numbers. This is evidence of the capability of our CMC and the capability of our team. Our team is made up of deep tech ceramic and polymer composite specialists, business and ops experts, startup veterans, and an amazing advisory team. We're at a very exciting stage. We're ready to scale. To accelerate our growth, we'd like to continue to develop relationships with investors, with customers, and with partners. So join us as we revolutionize the high temperature composite market. Thank you.
Ladies and gentlemen, hands together for our startup. Fantastic, come forward, well done. This right now is where we dig a little bit deeper and hear from our jury members about what they've just heard. I believe Florent from Saffron Corporate Ventures has a question. You can use my mic, yeah.
Yes, thank you very much for the presentation. Two quick questions. The first one, why do you prioritize aerospace compared to ground application like rail and even shipping, as you've seen on your roadmap? Despite certification being much tougher, is there something there that you think you have a special spot in aerospace?
Yes. Yeah. Is it on? Okay. Yes, aerospace is indeed much higher in terms of certification. But as part of our strategy, we can develop relationships and partners with companies that can help us develop to a certain certification. We feel we have such an advantage with our material that we think aerospace is a good place to go. But again, we're adaptable. So if a train manufacturer came along tomorrow and asked us to develop a material, then we'd very happily do it.
Thanks. And second question, in terms of IP, have you managed to protect what you've done?
Yes, so we've gone through an IP audit with a professional team, and it's a mixture of trade secret and protective ring of patents that we're in the process of developing.
Okay, thanks.
What is the maturity of your products? So you didn't elaborate on it.
Sure. So most of our products are at TRL 4. Verging into TRL 5, so we're just now starting to make more complex shapes using processing methods that would be for mass market. Thank you.
Wonderful. No more questions. All happy. Ladies and gentlemen, hands together for our startup high temperature material systems. Well done. Fantastic. Right. It's not easy, is it? It's not easy and it's not easy to pitch your idea to a group of jury members and also public as well in this industry naturally. And it's not easy to do this naturally in just 5 minutes, to be clear, to clarify everything and to get everybody to feel curious enough to have a conversation, because that's essentially what everybody here on stage is trying to do. Whether they'll do it or not, we'll find out a little bit later on. Again, you might be curious, you might be intrigued, you might like to know more. You can speak to every single one of our startups here on stage today and tomorrow as well. You can meet them after the pitching session, or even better, at the Startup Booster Village. You'll find that at the entrance of hall number 5, which is essentially just behind you, right? Everyone has their booth there, and a great idea, great opportunity to have a coffee, have a chat, and to learn a little bit more. Let's move on to our next startup. We move across now. Where have we been already? Denmark, UK, Germany, back to the UK a couple of times. Now we cross over to Italy. This is Italy. Please welcome to the stage our startup called RECARBON.
Every winter, we need more energy to maintain our daily lives. What would the world be like if we could dramatically reduce the energy required for winter? Based on various experiments and tests, we've developed nanowires that are 1/100th the thickness of a human hair. And using this, we made 3D nano heater that consumes up to 90% less power than conventional heating cables. This heater can be transformed into various shapes and is more durable than heating cables, withstanding pressures of 9T. We are currently working on a project with Hyundai Motor Company And we're also working on planning various other projects, such as road heating systems, smart chairs, heating pads, products for semiconductor industry, and products for the aerospace industry. We pursue nanotechnology in our daily lives.
I'm here to introduce groundbreaking solution. Will save electrical energy, can saving carbon emissions. We use and waste a lot of electrical energy to heat every corner of society, everyday life. Heating wire, which have been used for 100 years, has many problems but still used because of its low cost. Carbon emission from electrical heating account for 17% of global carbon emissions. To solve this problem, we developed 3D nano heater. 3D nano heater, made by electrospinning the fine copper nanofiber the size of 100 T of human hair, can heat the large area using low power. 3D nano heater, utilizing high conductivity nanofiber, can heat the 3 times more fast heat than heat wire, and can save up to 90% energy. Such as CNT and graphene, many material has been developed to reduce waste energy by heat wire. However, manufacturing method is complicated and expensive. They could not replace heating wire, but 3D nano heater can do. You are watching the world first developed 25 big area heater operating within 2 seconds. The performance is more than twice that of other heating elementary. If you press the 9-ton pressure, even if you make a hole in the surface during the operation, it will be okay without damage. This innovative material is safe and cheap and saving energy. From aerospace to automobile, this material should be used wherever heating is required. It's so effective to boiling water and melting the snow. Also, installation so easy. We have a lot of reference and prove to be very effective. Snow can be melted quickly and using small power. Automobile, heating jacket for pipe, various shape, various temperature. Smart chair. This innovative material can be used anywhere from home heating to construction site. Many companies interested in our material. We can supply it exclusively this huge market in the world. Our technology can be summarized 3 categories. 1, to generate copper nanofiber. 2, control copper nanofiber. 3, to create the device for the manufacturing copper nanofiber. All requirement and processing for producing 3D nano heater were developed with our own technology. We are looking for partners to join us in innovative adventure. Dreaming of nanotechnology in everyday life. Nano electronics. Thank you.
Ladies and gentlemen, hands together for our startup. Apologies again, jury members, I'm sure you're aware this is Nano Electronics, not RECARBON, it's Nano Electronics. I apologize for putting you off at the beginning. Right, let's move on now to our jury members and hear what they have to say or questions about what they've just heard. Yellow from Airbus, I believe you have a question.
Thank you very much. Could you elaborate a bit on what is the cost of your material, and is it cost competitive? Yeah, so does it have a business case? And also, do you have examples for the applications in the composite business?
Yes, we have I'm already explained to you. Our materials can exchange the heat wire, and then all everywhere heating is required, we can use. And the main section is a snow melting system. The melting the snow, we put under the road and can melt the snow. Maybe Canada, where the very cold area is need our material. Is okay?
And what about the cost?
Cost? It's difference. All the section is all each difference. But I'm sure that we supply it the low cost, like almost same the heating wire.
What about recyclability? Is there a constraint if you later want to recycle the copper?
The carbon emission from the electrical heating is really so big. And then if you exchange the heating cable and exchange our material, we can save almost 60% energy. And that is calculated almost the 10% reduced from total carbon emission of global.
That's it. We only have 10 seconds. If you can ask a question in 10 seconds, go for it.
Yeah, I can try. In terms of performance, how does it last in time, in terms of life cycle? Do you maintain the same performance?
Maintain also is so easy. And then our material, we already tested over the 3 years. It's no problem. Really long time can use.
Ladies and gentlemen, hands together for our startup here on stage from Korea, Nano Electronics. Thank you so much. Fabulous. Right, we move on now to number already. This is actually our 7th starter already. So we've heard 6 big ideas, all diverse, all well-deserved being here as part of the 10 of products and materials category. Remember a little bit later on this afternoon at 4:30 on this stage, we move on to another 10 big ideas from our 2nd category. So make sure you're here a little bit later on if you're curious and you're looking for the next big idea in terms of innovation in this industry. Let's move on now to, we actually now go over to Italy for the next startup called RECARBON.
Thank you. Good. Thank you. Merci.
Can you hear me?
Hello. Oh, am I alive?
Can you hear me? It's live. Can you hear me? Yes. Yes. Okay.
Just put the mic here.
Can you hear me with this? Okay. So, my name is Luca Grati, and I'm the CEO and co-founder of RECARBON. Today, we're going to talk about carbon fiber, and this is what the market looks like. Last year, under 10,000 tons of fiber were produced, and 30% of that is considered waste. So, we need to find a solution to the growing request of carbon fiber and the waste accumulation that happens every year. We need to make our market more sustainable. This is why we created RECARBON. RECARBON gives new value to carbon fiber waste, creating new intermediate products made of recycled carbon fiber. We can help you deal with any kind of waste. We can transform it into new intermediate products, and we give it back to the engineers and designers to make new components. Then why should you use recycled carbon fiber? It's high quality, so there is no significant performance loss compared to virgin fiber. It's cheaper than virgin fiber, up to 30%. Can be used where virgin carbon fiber is normally used, and it is good for the environment. This is a list of our product line. We have thermoplastic organosheet, thermoplastic sandwich panels with our patent-pending technology, and thermoset prepregs, thanks also to our friends at FiberTech Group. And this is what the market looks like. We are in a very high-paced growing market, and we think we can take advantage of that for the next few years. This is the team. We are a young team, but we already have a lot of experience, and we have great advisors behind us, like Maya and CBS. This is what we have done in the automotive market. We have made some parcel shelves, underbody panels, and other components, always keeping the production cycles very short, 3 minutes or less, achieving 45% in weight reduction and 50% less CO2 emissions. This is what we have done in marine market. We have worked with FIM on the Regina 440 sealing and with NL Comp with the EcoRacer 30 engine box. And industrial market, industrial machinery panels together with 3A core materials and with the Levante solar panel origami structure. So this is a list of who already chose us. There are customers, collaboration ongoing, and awards. But there is more. This is a worldwide movement, so we expect to have an increase of interest for recycled products and for sustainability in general because of laws, public policies, reform, and we hope common sense. And this is where we are aiming. So we want to give the market a complete turnkey solution. So if you want to embrace circular economy, you can do it with us locally. So if you're using carbon fiber, glass fiber, wood, let's work together. Let's have a chat. If you are an investor, we are open to investors right now. Thank you.
Ladies and gentlemen, hands together, right? Hands together for RECARBON. Well done. Let's come forward slightly. That's right, just here. Let's hear from our jury members right now. I believe Florent is going to ask us a question.
Yeah, thank you very much for the presentation. I had a question. How do you typically partner with the corporates that you've mentioned? And is there a difference between the three products? Are there all of them on the same type of business model, or is there a discrepancy here?
So yes, usually working with big corporation, we have to work together. So it depends on what kind of waste do you have, what do you want to do with your waste, and what kind of products you produce, basically. Because depending on the waste you have, we can usually suggest some applications for the waste, the recycled product. So you can use it back in your own production that you already have. So there's no difference in machine availability or something else. You can use our product directly into your own processes. And there are no differences for our products because, of course, they are based on thermoplastic and thermoset resins. So it depends on the application. Both are available at an industrial production rate.
And on the cost saving that you were mentioning, the 30%, where does it come from?
So in many things. Of course, it's the fiber itself. So we tested our products onto real application, and the 30% you've seen in the slides is related to, for example, a mold, which was made in carbon fiber, of course, virgin carbon fiber. And with our recycled products, you can do it with, of course, lower impact with CO2 emissions, and at the same time, we make it cheaper, up to 30% cheaper. So it's a real application that we tested, and it's the same thing we are doing with other applications. Like, for example, the underbody panels are made usually in glass fiber. We did it with carbon fiber, recycled carbon fiber, and you have like 45% of weight reduction. So it's both price and CO2 emissions.
And that's it. 2 minutes already up, ladies and gentlemen. Hands together for RECARBON. Well done.
Thank you.
There we are. Already, that's 7. We've heard 7 already, believe it or not, 7 big ideas. About to hear the 8th. That was Italy. We move across now from Europe, right across to the US. This is, again, put your hands together for our next startup called Sargassum Eco Lumber.
Hi, everyone. My name is Raquel de Antonio, and I'm the co-founder of Sargassum Ecolumber. We are all here looking for sustainable solutions that benefit our planet. For us, it was like fate. When a few years ago, my father and I went to a wedding in Mexico and the beaches were covered by this brown seaweed. My father, who is an inventor and a mechanical engineer, he felt very curious about it and took some samples for further testing. Then we fast forward to last year when I was reading the Miami Herald, and I saw that Miami authorities were looking for solutions and ideas on what to do with sargassum. And that's where our story began. Miami, Mexico, Puerto Rico, West Africa, and several other countries invest millions of dollars to keep clean beaches. But the sargassum issue persists. Now governments and authorities are waking up that this is a big problem and something needs to be done. On the other hand, we're all very aware of the plastic crisis. Plastics take forever to degrade, turning into microplastics that enter our seafood and finally into our bodies. So we look at these two challenges and thought, why not turn the problem into the solution? And we created Sargassum Ecolumber. Our product stands strong in the construction industry by manufacturing 4x8 panels in various thicknesses. Some of the qualities of our product is that it's extremely strong and durable. It is isothermic, it's rust, rot resistant, water resistant, it's very easy to work with, it self-extinguishes, and of course, it is eco-friendly. The global plywood market was estimated at $55 billion in 2023. The US plywood market was estimated at $21 billion. So if we capture 1% of the market, it's $230 million in revenue. Our target markets are the construction and home improvement stores. But it can be applied for an infinite number of applications. For example, it's perfect for flooring for maritime containers. Our model is business to business, and it's all about scalability. As demand grows, we grow just by adding more and more machines to meet the demand of the market. We like to say that at the core of Sargassum Ecolumber is sustainability. The reason we say this is because sargassum absorbs carbon dioxide from the atmosphere. What is happening right now is that the sargassum is being collected from the beaches, but it is then thrown away into the landfill where it decomposes and releases back the CO2. But by creating Sargassum Ecolumber, we are creating a carbon vault into the lumber. Of course, we are preventing deforestation by saving trees, and we are a perfect example of a circular economy. Our process is very simple and straightforward. First, we collect the sargassum from the beaches, then we dry it up to 14% humidity, then we process the plastic, create a mixture with the dried sargassum and the processed plastics that is injection molded and fed into a 3,000-ton press. The final step is the cooling and finishing of the panels. This is our team. Andres de Antonio is the co-founder. He's the inventor, mechanical engineer, and he's also my father. He has decades of experience in the composites industry and manufacturing and designing machinery. This is me. I'm the co-founder. I'm a business strategist and marketing expert. I have 30 years of experience in business development, and I've also been an entrepreneur in different ventures in the past. At the current moment, we finish our research and development. We have a finished prototype and a patent pending technology, and there's been a strong interest in the industry. So if you want to learn more, please reach out to me after the presentation. Thank you.
Ladies and gentlemen, hands together for Sargassum Ecolumber. Fantastic. Right, let's find out how this settles with our jury members. Chris?
Super interesting presentation, thank you. Quick question. Bioproducts are always a bit of a challenge because they typically grow, or they have to be harvested, or they arrive on the beaches during July and not in November? How do you manage the variability of supply?
Well, I've been asked that before, but there is a lot of sargassum coming. Every year comes more and more. So right now, to put it into perspective, only in Miami Beach, it was collected 17 miles of sargassum. And that gave us 400,000 panels. And it's just 17 miles. If we collect the sargassum from all the coastline from Florida, it gives us for 7 million panels, only in Florida, and not counting Mexico. So, I mean, we collected the years that it comes, and then we store it for the future.
Cool. And then another question, in terms of the processing, I see that you're pressing. Have you tried extruding it and making continuous panels?
Yes, it can be done like that too. But the best thing is injection molded, and the equipment is proprietary technology designed by my father. So it's a press that at the same time injects the mixture and then press it at the same time.
Cool. Thank you very much.
30 seconds on the clock. Happy? Quick question, quick answer? No? All good? All good. Ladies and gentlemen, hands together for Sargassum Eco Lumber. Well done. Well done. There we are. Again, you can, as you hear, very diverse, all different, and you can hear that sustainable element popping up throughout literally all of these big ideas here on stage. Who chooses? You don't have to do it. I don't do it at all, but our jury members certainly do. They will decide on a whole range of ideas in terms of the scalability, in terms of the team, in terms of the big idea, in terms of on the sustainable element as well, and they put it all together, and then tomorrow we'll find out who's the winner of this category, our second category, a little bit later on. And remember, there's also the best sustainable solution as well, which could be any one of the 20 finalists of Startup Booster 2024. Let's move on now to our next big idea. Next big idea coming from, we've been across Europe, we went across to the US, we come back to Europe, to Portugal, and this is SpacEngineer.
Welcome to SpacEngineer journey. My name is Nelson Oliveira, and I'm your guard angel. SpacEngineer is a company created in 2019. In 2019, I received this answer. A A400 Airbus was hit by a bird. I saw, okay, let me see if this is a big problem also. I saw that 10,000 these bird strikes happen every world, and this can cost almost 1.5 billion. We tested, and we saw that in carbon, in carbon, the material was easily penetrated by an ice ball. Unfortunately, the video is not working. But how I can overcome this issue? So we developed a smart material. A smart material named Impact to Space. A material that is a gel in normal state, but when you receive an impact, becomes like a solid. Integrated in standard carbon, using the standard technique, we are able to overcome the solutions. As you can see here, an ice ball hitting at 200 meters per second in a 2 millimeter carbon by 500 by 500 was not penetrated, absorbed all the energy, and the person that was behind was well protected. Our technology is greenable, superior impact protection, and as a must, is 10% lighter. Compared to the standard carbon, we can use it in helicopters, air taxis, satellites, and drones, and of course the standard aircraft. So comparing to the standard technology, we are lighter and we have more impact protection than the current standard materials. So how we can sell it? We can sell it in our hard material, or you can sell it in carbon. For most of the manufacturers in the world, composites or aeronautic. So our team is composed by 4 people with more than 25 years experience in composites, product developer, and business developer. We were created in 2019. In 2019, we participate in Airbus Biz Lab and also in MIT, Portugal, where I made my PhD. In the same year, next year, in the following year, we were in ESA, where we validate. And last year, we worked in an Israeli program called Astra, that is a collaboration by Starburst and AI. Currently, we are asking for 1 million euros for achieving the market as fast as possible. Thank you very much. Help us help you protect your assets. Thank you.
Ladies and gentlemen, there we are. SpacEngineer, come forward slightly. Let's hear from our jury members about what they've just heard. I believe
thank you for your presentation. You say it's green. Could you elaborate a bit? Why is it green?
Because our smart material is based by bio-based material. It's a combination by several materials that we can find in our food industry, as ascorbic acid, glycerol, and other materials that can easily integrate in chemical reaction and obtain the protectant that we need.
Any other questions, perhaps?
The full, if we look, for example, for an aircraft part, is it the full component that is built with your material, or is it only a cover in order to have the bird strike protection?
That is a nice question. So you can do both. You can do only the area where you need to protect, or can you do the full part? For example, the cone, the wing, or the fuselage. When we were in Airbus Biz Lab, the idea was only in the parts that were more suitable to receive the impact, but depends on the manufacturer.
Happy? I think we are. I'm looking at you. You're looking at us. You're looking happy. You're looking happy as well, and our audience as well. Ladies and gentlemen, hands together for SpacEngineer. Thank you so much. Wonderful. That way. Right, let's move on. Already, ladies and gentlemen, we are now on the very last startup. Let's hear our last big idea of this category right now. Please welcome to the stage from the US, ZILA BioWorks.
Hello, I'm Jason Purakel, CEO of ZILA BioWorks. At ZILA, we're developing innovative biomaterials and processes that meaningfully prioritize people, planet, and performance. Epoxy resins are a type of industrial plastic used everywhere, including composites, coatings, and adhesives. Unfortunately, the 4 million tons of epoxy resin we use globally each year have a heavy carbon footprint. Additionally, epoxies and all the other materials in epoxy composites are not recyclable and end up in landfills. ZILA uses vegetable oils, like hemp seed and linseed oil, to create a high-performance, drop-in bioepoxy replacement for a number of different applications. We've identified clear steps to a 60% reduction in carbon footprint compared to petroleum-based epoxies at pilot-scale production, and our Vitromere technology can help manufacturers deal with the end of life of their products. For 80 years, the chemical industry has used bisphenol A as the backbone for epoxies and other plastics. The few bioepoxy competitors on the market still use bis A, however, combine it with a bioepichlorohydrin to give them about 30% bio content and a 14% reduction in carbon footprint. ZILA's patented technology doubles the bio content and has the potential to cut embodied carbon in half compared to our nearest competitor without losing performance. ZILA is more than a bioepoxy manufacturer. We are a custom formulator, providing the highest value add in the epoxy supply chain so we can sell our bioresin systems to our product partners without any retooling needed for adoption. Margins are expected to be at between 15 to 25% at commercial scale, depending upon application. Epoxies are a $14 billion global industry and growing. Our go-to-market strategy starts niche, then expands. We've started with the ski and snowboard industry as the most accessible early adopters who can give us rapid feedback and help us demonstrate viability in demanding real-world environments. That industry is quick to adopt new technologies, they have high margins, and they require high performance standards. We're now moving to ski OEMs that use a pre-preg process for higher volume production. This will then open us up for more traditional sports, including rackets, clubs, bikes, and helmets. These early adopters will help us scale to the mid-size market, specifically the floor coating industry. Floor coatings is a much larger market segment than the outdoor industry, with over $800 million in sales per year in the US alone. Serving those mid-sized customers helps us to increase production capacity to reach larger market segments, global manufacturers in sustainable energy production and transportation. We have passed prototype and on-snow testing with several ski and snowboard manufacturers in the US. We're aiming to complete limited production runs with each in the next winter season. We have shipped samples of our wet layup resin system to a couple of ski OEMs that have expressed interest. We are currently working to formulate for pre-preg using glass, carbon, and natural fibers now. We just completed our floor coating ASTM and VOC testing along with an in-situ demo with excellent results. Next step, a high-profile paid pilot. Vestas, the world's largest wind turbine manufacturer, consumes approximately 100,000 metric tons of epoxy resin per year. After winning the Vestas Innovation Challenge, we formulated our bioepoxy resin for wind turbine blades. Not only did our bioepoxy perform better than a petroleum-based epoxy, in the lab we were able to demonstrate recyclability of both the bioepoxy and carbon fibers in full-length tact. We're excited to announce that ZILA is now part of the Shell Game Changer Accelerator powered by NREL to build and test a 1-meter turbine blade using our bioepoxy. We have a clear path to scale up and commercialize our bioepoxy resin platform technology in multiple market verticals. We have an amazing leadership team. Evan is a world-class athlete and engineer who has taken ideas from napkin to full-scale production. Andy is a 17-year veteran in the outdoor space. Keith Ann is a multidisciplinary scientist and research director with international academic and Fortune 500 corporate experience. Brad has experience in international finance and taxes. Myself, I've been working in sustainability for over 15 years, assembling and managing highly effective teams. ZILA has raised about $2.9 million to date, about a third in grants, and we've been recognized around the globe for our innovative technology that reduces the carbon footprint for materials critical to a circular carbon economy. We're currently raising $1.5 million US on a convertible note with half the round already closed. These funds will provide us with 12 months of runway to achieve 2 significant milestones: scale resin production and secure purchase orders in the outdoor industry. Thank you for your attention. I'm happy to answer any questions that you may have.
Ladies and gentlemen, hands together for ZILA BioWorks. There we are. Glad to come forward. Right, let's hear from our jury members. Karl-Heinz, you have a question?
Yes, sure. Thank you very much for your interesting presentation. I have 2 questions.
Please.
What about the cost of your new system? And the other question is your technology focused on epoxies, or could you this expand also to other resin systems?
Thank you for the questions. On cost, we believe that we can achieve $10 a kilogram cost of goods sold at pilot scale production. And of course, we'll gain efficiencies as we scale up beyond that. We've also started looking from moving from batch to continuous processing, which will drop OpEx, CapEx, as well as our carbon footprint. And I already have some proposals from some R&D partners to help us move from batch to continuous. With regards to other applications apart from epoxy, we are hyper-focused on our epoxy technology right now and getting it to market. However, yes, we can use that same technology for other applications such as polyols, etc.
60 seconds on the clock, Chris.
Hi, nice presentation. Quick
Thank you.
question. Can you retrofit an existing epoxy asset and put this technology in it?
Retrofit an existing epoxy composite application?
Well, no, retrofit an existing epoxy manufacturing plant and put this technology in it.
Essentially, yes, we believe that we can. We still use bioepichlorohydrin in the final step. There's specific, synthetic pathway that may be different in terms of the inputs and the materials going in. but absolutely, we think we can manufacture in higher volume with some of the strategic partners that we're hoping to speak with today and this weekend at JEC World.
Good luck, Jack.
Ladies and gentlemen, hands together for ZILA BioWorks. Thank you so much. Right, there we are. Guess what? We have just been through 10 big ideas here on stage, all very diverse, all very different. This is where our jury members, they will go off very shortly, off to a part of JEC World, which nobody really knows where.
Hello.
But it will be very, very quiet.
I'm
and
looking for someone to dismount the...
Together, they will decide who walks away a winner. And we will find out that a little bit later on tomorrow when we have the award ceremony of Startup Booster competition. But remember, later on today at 4:30, we do this all over again with another 10 big ideas from the next category, process, manufacturing, and equipment. So again, be here. If you're curious, you'd like to know more, be here at 4:30 to listen to another 10 big ideas. I thank our jury members, Karl-Heinz, Jelle, Florent, Rebecca, and Chris. They'll be back with us a little bit later on. I will be as well. Enjoy your day, but remember, back here, 4:30 for more Startup Booster 2024.